Hi everyone, this is Dr. Amit Kumar Pandey from ABES Engineering College. I am going to discuss threats and their management in this lecture. So let us see one by one what are threats and how can they manage. So in this lecture, topic will be introduction to threats, type of threats, benefit of using threats, threat life cycle, threat management, and conclusion. So what are the threads? A thread is the smallest unit of a process that can be scheduled and executed by the CPU. Multi-threading, the ability of a CPU to execute multiple threads concurrently, and threads enable more efficient use of CPU resources and improve application performance. Threads we can understand easily. Suppose there is a process P1 and P1 want to perform a number of tasks, many tasks, or you can assume that you have a long code in which there are number of modules, module 1, module 2, and so on. Okay, then that the whole program will be processed. And if you separate these modules as a process, then this will be child process of P1, child process CP1 of P1. This will be child process CP2 of P1. Now, so threads are lightweight process. So thread is the smallest unit of process that can be scheduled and executed by the CPU. What is the multi-threading? The ability of a CPU to execute multiple threads concurrently. है The number of process, number of sub-process, child process threads are executing parallelly, currently at the same time. Threads enables more efficient use of CPU resources and improve application of performance application. Types of threads. There are mainly two types of threads, user level threads and kernel threads. User level thread managed by user level library. Context switch is faster in user level threads. No need of kernel. For example, POSIX P threads. The second category is kernel thread managed by the operating system, not by the user library. Context switch is slower rather than user level threads. Everything is done with support of kernel, where there is no kernel support needed in user level thread. For example, Windows thread, Linux thread, any operating system process and sub-processes can be considered as kernel level threads. Benefits of using threads, concurrency. A word will be with concurrency. In concurrency, there are multiple threads can execute simultaneously so that the overall speed of application will enhance. Resource sharing, threads within the same process share resources such as memory and file. Responsiveness, applications remain responsive by the delegating long-running tasks to separate threads. Scalability, efficiently utilize multi-core processor to perform parallel computation. These are the benefit of threads. Thread lifecycle, new thread, runnable thread, running thread, blocked thread, without waiting thread, or terminated. If you remember, all these stages are discussed in process transition diagram or process life cycle diagram. Okay, again, what will be the life cycle of a thread? New, new created thread are here, and one by one, these threads are picked and put inside the ready queue. From here, processor will pick a single thread at a time, one by one, with the help of STS, short-term scheduler, and thread will be in running state. Okay, and after getting execute, it will terminate. Meanwhile, if thread want to do some IO operation, then it is put inside waiting queue from running to waiting, and when the IO is completed, it will again go inside the ready queue. Okay. This is the simple thread life cycle. Okay. Thread creation using thread libraries, जैसे POSIX में होता है आपका p thread create, thread in Java, attribute setting thread attributes like stack size, priority, scheduling policy, and how can thread get synchronized. So we use mutex, ensure mutex, that mutual exclusion to prevent race condition. Semaphores, semaphores are basically signals. These can be binary or counting to control access to resources. Monitors high-level synchronization construct. Thread scheduling, preemptive and cooperative. In preemptive scheduling, what we mean by preemptive scheduling, the OS decides when to switch threads. This is preemptive scheduling. Cooperative scheduling is threads voluntarily yield control. Means OS will not decide, they decided mutually. Conclusion of the lecture is threads are essential for efficient CPU utilization and responsive application. Understanding thread types, life cycle, and management is crucial for developing robust multi-threaded applications. Here are some references I have used in my PPT. Thank you for being with me in my lecture. Thank you all.